Hey guys, welcome back. I hope you all did wonderfully on your ACT. Today we're going to be talking about or continuing our discussion about osmosis, which is the process of moving water high to low. This is our last topic that's going to be included in your cell transport test on Tuesday, October 30th. You have a test Tuesday, October 30th. It's going to be about passive transport, active transport, the cell membrane, and osmosis. All right, Tuesday we were talking about osmosis. I know some of you were very confused. The main things that you're going to take away from it, we're going over today. So there are three types of solutions that can affect how a cell responds. That's isotonic, hypotonic, and hypertonic. So I'm going to just quickly go over it. The words that I wrote up here are your basic annotations for these words. So in an isotonic solution, the environment in the cell is the same as outside the cell. So there's going to be water leaving and water entering at the same rate. Nothing about this cell is going to change. This is what your cells are striving to do, or the environment that they want to be in. Hypotonic means that there's a lot more water entering than there is leaving. So the cell is going to get a lot bigger. Hypo kind of reminds me of hippo. Hippos are big. So the cell is going to get a lot larger. This is what can happen. It can get so big that it can burst. This is what happens if you drown, or if you have too much water, your cells will fill with too much water and then they would eventually burst. Hypertonic is something when you have a cell and you have a lot of water leaving the cell than coming in. This is what can happen when your cells are super dehydrated. So if you're not drinking enough water, then your cells can shrink. So if you've ever had a headache or something, it could be due because you're not drinking enough water. The way I like to remember it is hyper is like you're super excited. Think about like 8th period at 4:10, you're like really ready to leave. You're super hyper about it. And then you like dart out of school as fast as you can to go home. What I want you to do now is you have statements to the left here. I want you to match the statement to the different types of solutions. So pause the video and then do that now. All right, welcome back. So check yourself. And we are going to go over specifically what a solution is because we're talking about three different types of solutions. You should know what a solution is. All right, you've probably seen solutions a bunch. One example would be Kool-Aid. All right, so you have your cup of water and then you can add your Kool-Aid to it. Once you add your Kool-Aid to the water, it's like that powder, but when you mix that Kool-Aid around in the water, the whole glass turns a shade of red. What does that have to do with solutions? All right, the solute is the thing that's being dissolved or mixed in, and in this case that would be the Kool-Aid. And then the solvent is the substance actually doing the dissolving. In this case that would be the water. So like always, remember to be too cool for school. Hopefully you get my joke. All right, if osmosis is super not making sense to you still, I would recommend watching this video. It gives you an actual example of what happens to cells. This is going to be under the Google Classroom assignment. All right, let's look here. So I'm going to go over like how to break this down in an actual problem, and then you'll get some chance to practice for a couple. All right, so I know that water, anytime I see osmosis, I'm going to write that water moves from high to low. This picture is showing me a cell. That's the inside of the cell, and then everything outside is the outside of the cell. This is showing me a solution of salt and of water. I'm only going to focus on the water part because we're talking about osmosis. Remember, I need to identify first where does the high concentration and what is the low concentration. In here, the higher number is 95, so I know that inside of the cell has a high concentration of water, and 5 is lower than 95, so this has the lower concentration of water. Water always moves from high to low. Therefore, water is going to be leaving the cell, making this a hypertonic solution. I'm going to fill in these blanks over here to that effect. Water is going to flow out of the cell, and then the cell is going to, if water is leaving, will shrink. It could be shrink, wilt, get smaller, all of those things. Flip your page. In questions that it doesn't actually give you a setup problem, like the ones above, I'm going to show you how to set it up. All right, it says a cell with 95% water. I'm going to draw a cell and write 95% water. I'll write H2O because it's faster. It is placed inside of a beaker. Beaker is just that glassware cup that has 100% water. It says the membrane is not permeable. Permeable means pass. So it's not permeable to salt, meaning salt can't pass through the membrane, but water could. I will identify my high concentration that's outside the cell and my low concentration inside the cell. Remember, 95 is lower than 100. Water always flows from high to low. Therefore, water is going to enter, making this a hypotonic solution. So my cell is going to get bigger. Other words for that would be swell. It could potentially burst. All right, I know that this process was about osmosis, not diffusion, so I can eliminate A and B. And then between C and D, shrink is something that happens during a hypertonic solution. I've identified this as hypotonic, so I know that my answer is C because it will swell. Your job is to go through and annotate the rest of these questions like I just showed you. You are doing all the way to the end here. So let me know if you have any questions, but get started.